In this video, we're going to start talking about something called the matched pair t-test. First, let's review. A coffee dispensing machine is supposed to deliver 8 ounces of liquid into each paper cup, but a consumer believes that the actual amount is less. As a test, he takes a simple random sample of 30 cups of the coffee and measures the amount of liquid. He finds an average of 7.85 ounces with a standard deviation of 0.91 ounces in his sample. Is there evidence at the 0.01 level that the coffee machine is dispensing less coffee than it should? Well, let's start with our null and alternative hypotheses. So our null was that mu was equal to 8. Our alternative is that it's less than 8. And mu is the average amount of coffee that we're getting. Okay, so there's our state. Our plan. Well, we plan to do a t-test. We had a simple random sample. 30 is less than or equal to 1/10 all the cups that are filled. And of course 30 is larger than, or is greater than or equal to 30, so we can assume we have a large enough sample to proceed with this t-test. So now let's put this right over here where I have some room. So I went into my calculator, the t-test. We've got the stats. Our null was 8. Our sample mean was 7.85, deviation 0.91. 30, make sure that the inequalities match, and then I'm going to draw. So here's what I see when I draw. You can see my t-statistic and my p-value. So here's what I'm going to do. Let me slide this down. I'm going to write that the t-statistic was negative 0.9028 with 29 degrees of freedom. Please remember that if you don't report the degrees of freedom, you have not truly said the test statistic here. P-value 0.187. Now let's conclude. All right, we would fail to reject the null. Again, it's because our p-value is greater than 0.01. So what that means is we do not have enough evidence to say that the machine is not working as advertised. Sorry that my writing is getting so sloppy. Okay? All right, let's talk matched pair. A matched pair test is honestly one of the most missed tests that people they don't think about. And the reason is there is no matched pair in your list of tests. You know, we go to that stat tests menu. There is no matched pair. It really is like a modified t-test. Okay, so we're still going to be in that same t-test spot. It's just this modification is that the null is always that mu is 0. So that's always what will appear in that first line. But there is no specific test in that menu for it. You're just using the same t-test we've been using. Here's how we use the match pair. It's used really in two ways, that we have two very similar things that we're comparing to each other, that it is important that they're matched to one another. For example, I have a plot of land, right? So it's got the same soil and sunlight, and of course rain would be similar there. I have a treatment and a control group, and you know, I'm testing like fertilizer or something, and in the end I check the treatment group, the control group, and because it came from the same plot of land, I should be able to have a nice comparison. But again, if you know, you wouldn't seed the whole thing with this new fertilizer and then go to a spot with different rain and shade and compare that. It's important that these things are matched to each other. Another example is comparing something to itself, like a before and after. Okay, so I kind of jokingly put the old picture of the old ads for Hair Club for Men, right? That you say, well, this is what the man looked like before, this is the way he looked like after. But again, we're comparing one man to himself before and after. We wouldn't compare one man to a different man. We wouldn't say, well, before man one had this much hair and now man B has this much. That wouldn't make sense. We're comparing a person to themselves. So it's important that they're matched to each other. But again, all of these things, this one and this one, both examples, we boil all of the numbers down, all of the data down to a difference. And that's why mu is equal to 0. We began with this idea that whatever we're testing, whether it be a new fertilizer on soil or the Hair Club for Men, it didn't make a difference. So that's why we start with the idea that mu is 0. Let's do an example. I think it'll make more sense once you see that. So Dr. Zapp, this used to be an ACT preparation course that students could take on Saturday. So you always took like a pre-test at the beginning and a post-test at the end. And of course it was just like a half-hour sampler that would project your score. So what you see here is 15 students, their pre-test and their post-test. And then the difference. And the difference I did is post minus pre. Okay. Now, I want you to notice, again, what we were talking about, the importance of pairing a student to themselves. It wouldn't make sense to say, where's the one I want? You see, like, student 14, they went from an 18 to a 21. So they went up by 3. But yet, student 10 went from 29 to a 26. They went down by 3. But notice, student 10 is still higher than student 14. And that's why it doesn't make sense to kind of unpair these things. Obviously, the data set it's important that the pre and post are paired for each student. We shouldn't be comparing student 1 to student 5, pre to post. And that's why this is a matched pair. And we then boil it down to say, not what was their pre and post overall, what was the average here and average here. That's not what we care about. What we care about is how much improvement the student made, how much of a difference there was. Okay, so again, we need to just be careful to make sure we see that testing the whole pre-test against the whole post-test is not the correct move here. We want to see what the difference was. So let's start with the null. The null is that mu is equal to 0, and the alternative is that mu is, I'm going to say greater than 0, because I did post-test minus pre-test. We're trying to show this program works and causes your score to go up. So mu is the average difference, and I am going to then, it's important here to make a note of which way we subtracted. So I did post minus pre. You'll sometimes see people do that with their subscript. They'll write like mu here, and then they'll write like post minus pre in kind of a subscript. And that's kind of nice to do too. Then, of course, you don't have to write it over here if you've chosen to write it as the subscript. All right, so there's our state. Our plan, we are going to do a matched pair, which is a t-test, okay, in our calculator. So we had a simple random sample, maybe. I didn't say, but we can say, you went and took a random sample of students. 15, this used to be a very popular program. This used to go on every single Saturday leading up to AP exams. So I'm going to say, all people that took the course, like all participants. Okay. And you'll notice, though, that we have a very small sample size. It's only 15. So we have to do a graphical check. And let me do a modified box plot real quick. I'm going to put the differences in my calculator. I'm going to put them into list 1 and then make a modified box plot of that. Okay, so I made the modified box plot. You can see that there are no outliers. I'm also going to, just as a reminder here, remember, you always need to use labels. You need to have a a number line on the bottom. You can't just kind of draw this random thing out in space. So this, what I'm seeing are no outliers and really not much skew. Okay, so we can proceed. So let's go to the do step of this. And let me shrink some of that down just so I have a little more room to play with. Okay, do. All right, we are doing a t-test. This time I have the data. Remember, always the null hypothesis for a matched pair is 0 because we're assuming that the difference was 0, that this program didn't work. My data was in list 1, and make sure, of course, the greater than 0. Make sure it matches to the alternative, and I'm going to draw this. So you see our t and our p-value. So let's write that down, remembering our degrees of freedom. T is 0.702 with 14 degrees of freedom, and our p-value 0.2471. And let's then conclude. So we failed to reject the null. The p-value, of course, is too big, and I just said then, if we're not rejecting the null, we're saying that we can't. We're still under the idea that it's 0, so we don't have enough evidence to say the course works. Because of course, what Dr. Zapp would like to show is that it makes a difference, that you will actually increase your score. The big takeaways here: matched pair. Always look, when you look at two sets of data side by side, ask yourself: is it important that the first piece of data on either side is paired to each other? Are we looking for an improvement or a change or a difference? Not in whole blocks of data, like a whole control group, a whole treatment group, but rather a specific entity that has been split or that we are testing before and after. Okay? And remember, it is just a t-test in our calculator where the null is that mu is 0.